Calculating a specific term of an AP. Welcome, everyone. Before we dive into today's lesson, let's take a moment to reflect on what we have already covered. In our previous subsection, we worked through the derivation of the general formula for the nth term of an arithmetic progression, or AP. Now that we understand where that formula comes from, we are going to shift our focus toward its practical application. Specifically, we will learn how to use this formula to calculate the exact value of any specific term in a sequence directly. This is a powerful tool because it allows us to find any term we need without the tedious and time-consuming task of listing out every single preceding term in the sequence. The general formula. Now that we have established the purpose of our lesson, let's look at the actual tool we will be using. To find any specific term in an arithmetic progression, we use the general formula. A sub n equals a plus, parenthesis, n minus 1, parenthesis, d. It might look a bit intimidating at first, so let's break down exactly what each of these symbols represents. First, a sub n refers to the value of the nth term that we are trying to calculate. Next, a represents the very first term in our sequence. Then, we have n, which represents the position of the term we are looking for. For example, if we are searching for the 10th term, then n equals 10. Finally, d stands for the common difference, which is the constant amount added to each term to get to the next. Once you understand these four components, you'll be ready to follow the step-by-step procedure I'm about to show you on the next slide. Step-by-step procedure for calculation. Now that we have seen the general formula on the previous slide, let's break down exactly how you should approach a problem. To avoid confusion, I recommend following this 5-step procedure every single time. First, you need to identify the first term, which we represent with the letter A. Simply look at your sequence and note down the very first number you see. Second, you must determine the common difference, denoted by the letter D. To do this, subtract the first term from the second term, which is written as a sub 2 minus a sub 1. A very important tip here: pay close attention to your signs. If the numbers are decreasing, your d must be negative. Third, identify the position, which is our n. You need to look at the question and see which specific term is being requested. For instance, if the problem asks you to find the 25th term, then n equals 25. Fourth, once you have these three pieces of information, it is time to substitute the values. Take your a, your n, and your d, and plug them directly into our formula. A sub n equals a plus the quantity and minus 1, all multiplied by d. Finally, you must simplify the expression using the correct order of operations. We will look at this in more detail in the upcoming examples, but generally, you should first subtract 1 from n. Second, multiply that resulting number by d. And finally, add the first term, a, to that product to reach your final answer. Worked example 1, mathematical application. Here we are presented with a problem. We need to find the 15th term of the arithmetic progression, which begins with the sequence 3, 8, 13, 18, and so on. To solve this, we will follow the systematic approach I just described. First, let's identify our variables. Looking at the sequence, our first term, which we absolutely call a, is 3. Next, we need to find the common difference, d. To do this, we subtract the first term from the second term, so 8 minus 3, which gives us a common difference of 5. Third, we identify the position we are looking for. Since the problem asks for the 15th term, our n is 15. Now we move to the fourth step, substitution. We take our formula, a sub n equals a plus the quantity n minus 1 times d, and plug in our values. This gives us a sub 15 equals 3 plus the quantity 15 minus 1 multiplied by 5. Finally, we simplify the expression following the correct order of operations. First, we handle the parentheses by subtracting 1 from 15, which leaves us with 14. Next, we multiply that 14 by our common difference, 5, which results in 70. Lastly, we add our first term, 3, to 70. This brings us to our final answer. The 15th term of this sequence is 73. Now that we have reviewed the formula and the step-by-step procedure, let's put everything into practice with our first worked example. It is a much faster method than writing out all 15 numbers, isn't it? Now, let's see how we can apply this same logic to a real-world scenario in the next slide. Worked example 2, real-world application. Imagine a student who has decided to start saving money in a piggy bank. In the very first month, they deposit $50. To build up their savings, they decide to increase the amount they save by $20 every single month after that. Our goal here is to determine a specific value. Exactly how much money will the student deposit specifically in the 24th month? First, let's identify our first term, which we call a. Looking at the scenario, the initial saving in the first month is $50, so a equals 50. Second, we need to find the common difference. Since the student increases their savings by $20 each month, our common difference, D, is 20. Third, we identify the position, N. Since the question asks about the 24th month, our N equals 24. Now we move to the fourth step, substitution. We take our general formula, a sub N equals a plus the quantity N minus 1, multiplied by D, and plug in our values. This gives us a sub 24 equals 50 plus the quantity 20 as 24 minus 1 multiplied by 20. Finally, let's simplify this expression step by step, being very careful with our order of operations. First, we handle the parentheses by subtracting 1 from n, which leaves us with 50 plus the quantity 23 multiplied by 20. Next, we perform the multiplication. 23 multiplied by 20 gives us 460. Now our expression is simplified to 50 plus 460. Lastly, we add the first term to this product, which results in 510. So, our final answer is that the student will deposit $510 in the 24th month. Now that we have mastered the pure mathematical application in our first example, let's see how this formula actually works in a real-world context. To solve this, we will follow the same systematic procedure we just practiced. As we move to our next slide, I want you to pay close attention to the common pitfalls that might lead you to an incorrect result in problems like this one. Common mistakes to avoid. Now that we have seen how to apply the formula in both mathematical and real-world scenarios, I want to pause and discuss some common pitfalls. Even if you understand the concept, it is very easy to make small computational errors that change your entire result. First, let's look at the most frequent mistake, using n instead of n minus 1. It is very tempting to simply multiply the common difference by the term number, but remember, we are not adding the difference starting from the first term, we are adding it for every step after the first. Because the first term is our starting point, the common difference is added exactly one less time than the position of the term. Always remember to subtract that 1. Second, please be extremely careful with sign errors regarding the common difference, or D in our previous examples, the sequences were increasing, so D was positive. However, if you encounter a decreasing sequence, such as 10, 7, 4, and so on, you must recognize that the common difference is negative 3. If you accidentally use a positive 3, your formula will calculate an increasing sequence instead of a decreasing one, leading to a completely wrong answer. Always check if your sequence is going up or down. Finally, never overlook the order of operations. When you plug your values into the formula, you must follow the standard rules of BODMAS or PEMDAS. This means you must first calculate the value inside the parentheses, which is n minus 1, then multiply that result by D, and only after you have completed that multiplication should you add the first term. If you add the first term too early, the entire calculation will be incorrect. Keep these 3 points in mind, and you will be well prepared for our final summary. Key takeaways. First and foremost, remember that the formula, a sub n equals a plus the quantity n minus 1 times d, is your most powerful tool. As we saw in our earlier examples, this formula allows you to jump straight to any term you need, saving you the tedious and error-prone task of listing out every single number in the sequence. Second, keep a close eye on your n value. The variable n represents the position of the term in the list, so it must always be a positive integer. You can't have a negative second term or a fractional 10th term. It always refers to a specific whole number position. Third, don't be intimidated by the common difference. D, as we discussed when looking at potential mistakes, D can be positive, which means the sequence is increasing. It can be negative, meaning the sequence is decreasing, or even 0, in which case the sequence stays constant. Always check your signs carefully. Finally, if you follow the systematic approach we practiced, which is simply a matter of identifying your variables, substituting them into the formula, and then simplifying using the correct order of operations, you will find these problems very manageable. All right, we have reached the end of our lesson. Let's quickly recap the key takeaways to ensure you have a solid grasp of how to calculate a specific term in an arithmetic progression. Great job today. Keep practicing these steps, and you'll master arithmetic progressions in no time.